While on the topic of discussing solving linear equations, there is another type of equation. We call them literal equations. Now, everything we dealt with yesterday only had one variable, right? We were solving for x or w or something like that. A literal equation means that you have multiple variables, multiple letters. So instead of solving for a number, when they say solve a literal equation, what they mean is rearrange it to get that particular variable by itself. So let's discuss what that means. So the big idea of this lesson, the big idea is when solving for a variable, all it means is to get it alone, okay? You want to isolate that variable so it's by itself. So for starters, the equation K equals C plus 273 relates temperatures Kelvins K and degrees Celsius C. So we want to know what is C in terms of K. So what it's asking for, if it wants to know what C is, it means get C by itself. So right now we have this equation. And if we're trying to solve for C, get the C by itself, well, all we have to do is subtract the 723. Or sorry, 273. So really C is just K minus that minus a 273 degrees. So again, that's an example of a literal equation, okay? I can rearrange that equation to now solve it for C instead of solving for K, all right? So basically saying that Celsius, you take the degrees Kelvin and subtract off 273. So we're going to practice this skill with other scenarios, okay? So if I have A equals 1/2 B times H, so basically this is the formula for the area of a triangle. And if I'm trying to solve it for B, I'm trying to get the B by itself, that's going to take two steps. There's that 1/2, and then there's the H that I have to deal with, okay? Now, the 1/2. So here, there's a couple ways you could go about it. You could think, oh, cool, I can divide off that 1/2. But dividing by a fraction just sounds like a lot of work, okay? A lot of work that I don't particularly want to do. So I would urge you to realize that to undo that 1/2, I could multiply by 2, and that will cancel off the 1/2. So that's the steps I'm going to take to make this just a little bit easier. If you have a 1/2, multiply both sides by 2, and the 1/2 is going to be gone. I still need to get the B by itself though. So to get the B by itself, I'm now going to divide that H away because the H is multiplying the B right now. So let's divide it away. Now I have a formula. Now it's rewritten to solve for B instead. That's how we deal with literal equations. So the next one, slope of a line, y equals mx plus b. If I want to solve for the slope, for m, what I want to do again is get everything away from it. Now you have to think getting everything away in the right order, okay? So if you have separate terms, so I have an mx and I have a b. If you have separated terms like that, the first thing I would do is move away anything that does not pertain to your variable. So what I mean by that is I'm actually going to subtract the b to the other side right away, okay? The b is in no way connected to the x, so I'm going to move it first. Now that I've done that, now to get m by itself, well, the x is multiplying it, so to undo that, I'm going to divide by the x. And now I have that equation that is solved for m. In our next one, we're being asked to solve for d, to get the d by itself. So I see two things happening to the d. Right now, it's being multiplied by c, and it's being divided by 6. So the first thing I'm going to do is I'm going to multiply both sides by 6 to cancel off that division. Okay, I like to alleviate the fraction first. So I'm going to multiply by 6. Well, it's going to multiply up to the top, so that's actually going to give me a 30a over b equals CD, right? Multiplying the 6 up to the other side. Now if you notice, the D is still being multiplied by C. So let's divide by C. Now when I divide by C and it's already a giant fraction, I'm just going to include it down on the bottom. Dividing by C, it's just going to put it on the bottom of the other side. And now I have something that is completely solved for D. And for the next one to get x by itself, well, this time I notice that the whole thing is a fraction. So the entire side is being connected by that 4. So the first thing I'm going to do is I'm going to remove that connection. I'm going to multiply both sides by 4. Because now, without that 4, now I'm going to be able to move the 3 over. Okay, now I'm able to subtract the 3 to get it to the other side, and my x is now alone. So that is how you deal with basic literal equations. There is another circumstance that can come up though. So sometimes you'll see that the variable is represented more than one time. Okay? You see it in multiple terms. So here you have a couple steps to take then. First step, you want to collect all the terms with that variable together. Okay? Collect them up all on the same side. Then you want to factor out that variable and divide by what is left. Okay, so make sure you jot down those notes for me because it's going to be really important because this is kind of a particularly tricky idea that I'm giving you. So, our first one, 3x plus zx equals 5. So the x is in multiple pieces, right? So really what we want to do is we need to pull that x out. It's in both terms, so I'm going to reverse distribute, okay? I'm pulling that x out. So again, basically, I'm just doing the opposite of distributing. Instead of putting something in, I'm ripping it back out, and we call that factoring. Now, the reason I'm doing that is because now, hopefully you can tell, now I only have one term that has an x in it. I only see x represented once. So now, if I divide by that z plus 3, or sorry, 3 plus z, now the x is by itself. Now I've solved this equation for x. Now what about on the other side, okay? The right-hand side. So this one has an added dilemma into it, okay? So now the x's are on opposite sides of the equation. So that's where you go back to the first step I mentioned, is that you want to get them together. So basically what that means is I'm going to take that 6x, I'm going to subtract it over. Okay, I subtract over that 6x, so now my x's are together. Because now that my x's are together, now, once again, I can rip it out. I can pull it out front. So now I only see it represented once. And because I only see it represented once, now if I just divide by that r minus 6, now I have my equation solved for x, and I am done. So again, that's the circumstance that you need to use whenever you see the variable you're trying to solve for in multiple places of the equation. Once again, thank you for joining me. Now that you're done writing down all of these notes, now please make sure you go and you do the associated worksheet.